beyond the realm of the familiar planets, past the gas giants, and into the cold, uncharted expanse of space. There lies a world so distant that the sun appears little more than a faint star. This world, Pluto, has long been a mystery, a lonely traveler at the edge of the solar system. For nearly a century, it was considered a distant, icy anomaly, a place too cold and too far to matter. Yet, when NASA's New Horizons spacecraft passed through this icy frontier in 2015, it revealed something astonishing. Pluto is not just an inert, frozen rock. It has an atmosphere, a dynamic, living atmosphere. This unexpected discovery changed everything we thought we knew about this dwarf planet. An atmosphere that breathes and cycles, one that defies expectations. And with each new detail uncovered, the mystery of Pluto's atmosphere grows even deeper. Pluto's journey into discovery began nearly 90 years ago, when astronomer Clyde Tombaugh first spotted the distant object far beyond Neptune's orbit in 1930. At the time, Pluto was just another tiny world, a dim speck against the vastness of space. It was thought to be a lonely, frozen rock at the outskirts of the solar system, too cold, too small, and too far from the sun to support anything more than a bleak, lifeless surface. For decades, Pluto remained a curiosity, a world distant in both physical and scientific terms. The technology of the time couldn't reveal much, and so we filled in the blanks with assumptions: a world with no atmosphere, no activity, no change. It wasn't until the 1980s, as more sensitive instruments began probing the depths of space, that we started to question this assumption. In 1988, Pluto passed in front of a distant star, and astronomers noticed a strange, slow dimming of the star's light. It wasn't an abrupt cut, as would be expected if the light were simply blocked by a solid object. Instead, the star's light faded gradually. The dimming was caused by Pluto's atmosphere, which refracted the light, bending it in subtle ways. For the first time, we had proof that Pluto wasn't just a cold, dead rock. It had something around it. It had an atmosphere. So how does a distant, icy world on the farthest fringes of the solar system manage to keep an atmosphere at all? The conditions on Pluto are extreme. Temperatures drop to minus 240 degrees Celsius on average, and its distance from the sun results in weak sunlight. Yet, against all odds, Pluto maintains a thin layer of gas. The answer lies in sublimation. Pluto's atmosphere is mostly made up of nitrogen, but it also contains trace amounts of methane and carbon monoxide. When Pluto is closest to the sun, its surface warms slightly, causing the ice to sublimate, turning from solid to gas. This causes the gases to rise into the atmosphere, where they form a tenuous, delicate layer of air around the planet. As Pluto moves away from the sun, temperatures drop and the atmosphere collapses, freezing the gases back onto the surface. This process is not one we see on Earth, but on Pluto, it's essential for the planet's atmospheric behavior. Pluto's atmosphere comes and goes, ebbing and flowing in a seasonal rhythm that stretches across centuries. It's a cycle that mirrors the planet's 248-year orbit, a time frame far beyond human lifetimes, where the atmosphere lives and dies with each orbit. In 2015, after a decade-long journey through the void, the New Horizons spacecraft arrived at Pluto, marking humanity's first close encounter with this distant world. What New Horizons uncovered was nothing short of astonishing. Pluto's surface was covered in vast plains of nitrogen ice, enormous mountains of water ice, and a heart-shaped region, now called Tombaugh Regio, in honor of Pluto's discoverer. But perhaps the most surprising revelation came not from the surface, but from Pluto's atmosphere. It wasn't just a faint, wispy halo around the planet, as many had imagined. Instead, New Horizons revealed something far more intricate, a blue haze that stretched hundreds of kilometers into space. These hazes were not just static, they were alive, dynamic, and varied in their structure. The images revealed multiple distinct layers of haze, floating in the upper reaches of Pluto's atmosphere. As scientists studied the haze, they discovered something remarkable. The haze is chemically rich. The upper atmosphere of Pluto is filled with hydrocarbons, complex molecules like methane, acetylene, and ethylene, which are broken down by ultraviolet light from the sun. These molecules combine to form tholins, dark organic particles that rain down to the surface, coloring Pluto's ice and creating its reddish surface features. This discovery was especially exciting because tholins are thought to be precursors to the complex organic molecules necessary for life. In fact, they have been detected on Saturn's moon Titan and in the atmospheres of comets. The presence of tholins suggests that Pluto may be involved in processes similar to those that took place on early Earth. Could Pluto, in its cold, isolated corner of the universe, harbor the building blocks of life? Perhaps Pluto is not just a frozen wasteland, but a time capsule from the early days of the solar system, holding clues about the chemical processes that might have led to life on Earth. Pluto's atmosphere is not static, it's alive in a way we didn't expect. Despite its distance from the Sun, Pluto's atmosphere behaves in ways that suggest it is more dynamic than we thought. As Pluto moves farther from the Sun, scientists originally believed that its atmosphere would gradually fade into nothingness, freezing back onto the surface. But that's not the case. Data from New Horizons revealed that even as Pluto moves away from the Sun, its atmosphere remains. In fact, it's been growing more complex, even at a distance of 7.3 billion kilometers from the Sun. This discovery is still puzzling scientists. It's possible that the atmosphere is being replenished by some form of internal heat, perhaps a phenomenon like cryovolcanism, cold volcanoes, or a subsurface reservoir of volatile materials keeping the atmosphere alive and active. Pluto's atmosphere may not simply be a temporary feature, disappearing into the dark void as the planet moves away from the Sun. It may be a long-term fixture, altering in ways we still don't fully understand. The implications of Pluto's atmospheric behavior are profound. Pluto is the most distant world we know to have an active, observable atmosphere, which suggests that there may be many more icy bodies in the outer reaches of the solar system with similar characteristics. The Kuiper Belt, home to Pluto and other similar worlds, may be a treasure trove of atmospheric mysteries waiting to be explored. What does Pluto's atmosphere mean for other worlds? Could Eris, Makemake, and other distant objects in the Kuiper Belt also harbor transient atmospheres, perhaps in their early stages? And what about Triton, Neptune's moon, or Ceres, the dwarf planet located in the asteroid belt? If Pluto, with its cold, distant orbit, can sustain an atmosphere, what does that mean for other planets and moons that we once thought inhospitable? Perhaps Pluto is just the beginning of a whole new frontier in planetary science. A frontier where life-sustaining conditions can exist in the coldest, most distant reaches of our solar system, hidden in ways we never imagined. As Pluto continues its slow, elliptical orbit, its atmosphere will inevitably change once again. When Pluto nears the Sun in centuries to come, the atmosphere will return, only to fade once more as the distant world drifts away. For now, though, Pluto remains a world of mystery and wonder, a world that breathes in the cold, dark expanse of space, its atmosphere a fleeting, seasonal phenomenon that defies expectations. Pluto is no longer just a frozen rock on the edge of the solar system. It is a dynamic world, a living planet that pushes the boundaries of our understanding of what is possible in the cosmos. As we look deeper into the mysteries of this faraway world, we are reminded that the universe is full of surprises, and that the most unexpected discoveries often come from the most unlikely places.